7 students on an intramural team weigh 192 pounds, 196, 187, 198, 186, 205, and 180. What is the standard deviation of the weights of these students? Okay, so calculating standard deviation. How do we do it? How do we calculate standard deviation? That's an important question. So let me lay out the rules first here. So standard deviation. Okay, so the first thing to do, step one is to we're going to list the values. So we're going to say the values. So let me just write them right on down here. So what were they? So 192, 196. 196, 187, 198, 186, 205, 180, and then we're going to go over here and do their average or mean. So we got to figure out the average. So if you add these up on your calculator and then divide by whatever 7, because there's 7 of them, let's find the average. So I'm going to add them up first on my calculator. I'm getting 1344. So there's the total. So then the average is 1344 divided by 7. That's the mean, which comes out 192. So the average value is 192. So what I'm going to do is I'm going to write the mean, the average value, 192, all the way down this list. And then what I want to do, standard deviation, let me give you a feel for standard deviation, is the average distance from the middle. So now I want to find out value minus average. So I'm going to subtract these. That one's just 0. Subtract these. That one's 4. Subtract these. That one's, just use your calculator. That'd be -5. Subtract these, that's 6. Subtract these, that's, I don't know, what is that, -6. Subtract these, that's 13. Subtract these, that's -12. Okay, so value minus average. And then the next column is going to be value minus average squared. So then you second power each of these. 0 to the second power is just 0. It doesn't do much. 4 to the second power is 16. Minus 5 to the second power is 25. 6 to the second power is 36. Minus 6 to the second power is also 36. Just use your calculator on these. 13 to the second power is 169 if you need to on some of them, like that last one. Minus 12 to the second power, 144. So now, that's the value minus average squared. Now we're going to add all those up. So it's kind of a tedious process. We're almost there. I'm getting 426. 426. Now, what are we doing so far? What are we doing? We found these numbers are how far each of these scores, these weights, is from the middle, right? There's an average weight, which is 192. That's the middle. That's the average, the middle of all these weights. And so this is how far each person is from the middle. Like this person's right on the middle. This person's 4 pounds heavier, right? 196 is 4 pounds heavier than the average. This person's 5 pounds under the average. 187 is just below the 192 average. This person's 6 above, 6 below, 13 above, 12 below the average. What we're trying to figure out is standard, meaning average or typical, deviation. That's distance from the middle. We're trying to find typical or average distance from the middle. In other words, how spread out is this data set? This is really going to be a measure of spread. We're trying to figure out how spread out are these data values. How spread out are they? In other words, how far are they from the middle? Are they way spread? Are there people that weigh, 290 pounds and people that weigh 101 pounds, and there's this gigantic spread, or are they all kind of clumped around the middle? What's the spread? That's what standard deviation is. It's standard, typical deviation, distance from the middle. How far are people from the middle typically, on average? And so what we did is we found the middle, 192, and then we found out how far each of the numbers is from the middle by subtracting. But the problem is you think, well, there it is, just average those numbers. Well, we don't want to average those numbers because you know what would happen if we added these up? We would get 0. Because the amount above and below the middle will come out to be 0 because it's the middle. So the amount above and below, will check it out if you want. Add those up in your calculator, right? You can see it'll come out to be 0. So we don't want to do that. So we have to square them all. Why do we square them all? Because that way we get rid of the negatives. We don't want the negatives to cancel out the positives and get 0 like we did here. So we square them all. It makes every number positive, when you square it. And so now this is the total. This is the total of all deviations, distances from the middle. Distances from the middle squared. So we want average. So what do we do then? To find average, you take that 426 and you divide by how many values? Well, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. Yeah, 7. That's right, we had it right here, huh? Over 7. So you get the average distance from the middle. So I'm getting 60 point, well, actually that'll be the average squared, 60.857. Here, I'll put a couple more spots. 857, 142, 14286. That's the average square. Why is it squared? Because we squared them all, right? So this is the total of squared, and then when we divide by n, we get the average squared, and then finally, if we take that average squared and we root it, we root the 60.85714, that's just a 1 there, 14286. Hit the square root of that button, we'll get the normal average. So at the very end, we have to square root to undo the fact that we second powered everything to get rid of the negative signs. So you have to hit square root, and I'm getting 7.8. They want me just to round to one place. So there it is, 7.8. That's what we call the standard or typical deviation. What does it mean? It's not only important to be able to calculate it, but to really know what does it even mean. Like what's the important? In real life, you'll read it here in the information age we live in. You'll for sure read studies and professional things in which they talk about standard deviation. You want to know what it means? It means typical distance from the middle. Meaning, in this data set, the middle is 192. In these weights, the middle is 192. Some people are right on the middle, some are above, some are below, etc., etc. Some are way above, 13 above, some are way below, 12 below, some are just a little above 4 or a little below 5, -5, 5 below. But typically, 7.8 pounds off of the middle. That's what that means. That means, on average, people in this data set among these 7 are 7.8 pounds from the middle. right? So that's how far people are from the middle, right? You can see that's about right? Some people are way above 13 and 12 below, and some are close, like only 4 or right on the middle. So on average, people are 7.8 pounds off of the middle. It tells you how spread they are. The average person is 7.8 pounds from the middle in this data set. Some are further from the middle, some are closer to the middle, but that's what standard deviation is. Average distance from the middle. On average, they're 7.8 pounds from the middle.